causing the graph that we see here, causing the dermatomes to change and create a certain thermal pattern across the back. But that same sympathetic stimulation, the fight or flight response that we learned about in high school, is also taking and reducing blood flow. Unfortunately, our little friend here, let me bring up my model. We're going to use him as an example. When the sympathetics are stimulated, blood flow to the smooth muscle surrounding viscera, and in this case, let's say a liver, a heart, all these little organs in here that this young fellow doesn't really need anymore, end up suffering from that state of fight or flight because the blood flow to the smooth muscle surrounding them is inhibited by the sympathetic system being hyperstimulated. This inhibition over time causes ischemia and problems that eventually will end up perhaps as a diseased organ. Not only does the sympathetic system cause this vasoconstriction and reduce blood flow to our friend here, when those organs become distressed as a result of that reduced blood flow, sensory nerves around those organs go back to the spinal cord, to the central nervous system, and reaffirm the sympathetic demand that is being placed on the body to vasoconstrict, and we have what we call in engineering a positive feedback loop, where we have a cycle that feeds upon itself. It may not. These sensory nerves and may not track up to the brain. There may be no sensation at all in the patient that this is going on. It's a very subtle and silent killer, if we will. Some of this sympathetic stimulation may or may not cause muscles to be taut. So palpation doesn't always show a subluxation. And there are other things that can cause muscles to be taut and tender. The most sensitive, the most accurate measure of whether or not the sympathetic nervous system is being stimulated is by recording and measuring skin temperature. What we find here is a person that is subluxated. The darker graph, there's 3 graphs here overlaid on top of each other. The darkest one is their pattern, and the other 2 graphs on top of this pattern graph, as you can see, are perfect overlays, almost as if they were traced. That is how reproducible a pattern, a thermal pattern, is in a patient that is subluxated. Do you remember that I mentioned that anything over 0.8 degrees correlated 96% with pathology? Each division on this graph, every one of these vertical lines, is 1/2 of a degree. We can see here on this patient that from left to right in this area, we've got 1 degree off this way, 1 degree off, and almost 1.5. We got a 2.5 degrees centigrade temperature deviation at this level. Remember, we measured distance, so we can precisely know where that level is. Now, that does not necessarily mean that the subluxation is in that area. Remember, we said that the lateral cell column is the beginning of the sympathetic system, but that we have a synapse in the sympathetic chain outside of the spinal cord. That synapse may occur several levels above or below the initiating area that is being hyperstimulated. Therefore, we cannot go to a graph and say where we have a certain temperature swing, that is the vertebrae that is being subluxated. That may not be the case. It may be in the lower back. We do find some pretty good correlation of where the adjustment was made and where the major swing was, but that is not necessarily the case, especially in the C-spine. Here's another example of someone in pattern. The darker red line is their pattern graph. The lighter line is the graph on the day they presented to the office. This particular graph is of our UPS driver, who, not surprisingly, is usually subluxated when he comes. These are graphs of myself. This was back in 1997. These graphs are a little over a month and a half apart. And what I want to point out here to you are the very, very subtle thermal deviations that present themselves on a body that is subluxated. When you look, and all three of these graphs must match, by the way, in order to say that that patient is subluxated and that you're going to decide to adjust. Because of these small deviations that are so important to determining pattern, this is a full spine graph, by the way, you can understand why the resolution of the scanner is very important. If we did not have a lens, if we did not have a culminating barrel, if we were averaging an area on the skin when we recorded our readings of an inch or more, we would never see these subtle changes in the graph. What does a clear graph look like? Okay. Here's a full spine graph. The red line is a beautiful post-adjustment clear. The black line was the patient's pattern of when they were subluxated. Also note that when subluxated and a patient is in this hyperstimulated sympathetic area problem, overall skin temperature, the vasoconstriction of the capillary beds in the skin really cool the patient down. Very cold actual skin temperature. When adjusted with the right listing at the right time, as BJ would say, in the right place, we brought up back to normal tone all those capillaries in the skin, bringing up surface temperature and balancing out the readings. And this is an indication that the sympathetic nervous system has been quieted down. We've removed, if you will, the popcorn from between the teeth. It takes a specific adjustment, especially in the upper cervical area, to perform and clear this well. This is the straight line graph that for 30 years in BJ's clinic in Davenport was the expected outcome assessment of every case. Why has that been lost in chiropractic? My guess would be that as the clinic approached the early 50s, there were not a lot of instruments available. The thermocouple devices were very expensive in the beginning. Instruments that were built after the NCM were not always very reliable. No one ever measured distance. No one ever was able to create very, very precise pattern graphs. Not trusting the instruments any longer, I believe that the profession sort of forgot what thermography was and forgot how it was used in the clinic and how powerful a tool it is. That is changing today.